Dr. Allen Eaves, the co-founder, along with his wife Connie, of the Terry Fox Lab concentrating on cancer, is also the CEO and founder of STEMCELL Technologies. That's Canada's largest biotech company, and he does it all from British Columbia. Dr. Eaves calls himself a passionate Canadian, determined to give our bright young scientists the opportunity to work, live, and stay in Canada. The research that has come out of this remarkable company helped lead to the development of COVID vaccines and has been a major player in bone marrow transplant advances. A man and a company to be recognized. Dr. Allen Eaves. Allen, what first inspired you to go into science?
Well, my father was a scientist. He was a specialist in fruit storage and actually pioneered controlled atmospheric storage for apples. You keep apples up to Christmas in a cold room, but if you seal the room off and let the CO2 go up and the oxygen go down, the apples can keep up to a year. He sort of pioneered that technology, and that was in Nova Scotia where I grew up.
And so that fascinated you?
Yes, but going into his lab, the smell of chemicals, and you felt you could change the world as a single person. There were real opportunities.
And then how did you become a doctor and you decided to go into that particular branch of science?
A colleague of mine in high school, her parents were good friends of my parents, and her mother got breast cancer and went on to die. And she had there were three kids in her family. And I thought, this is so unfair. I mean, she was a young woman. And I was looking for something to, what am I going to do with my life? And I said, I think I'm going to focus on cancer research.
And you did?
Yeah.
And lucky for British Columbia, you came out to Vancouver, and along with Connie, your wife, you were the co-founders of the Terry Fox Lab.
Right. It was a great time. We had a lot of support from the Cancer Agency and the university, and we got $1 million from the Terry Fox Run that was going to stay in British Columbia. And that was the beginning of what was a fun and very productive enterprise, where we trained, well over 100 graduate students and had a whole clutch of well-trained people helping us do our research.
And did you find that there were lots of science students eager to get into research or not?
They were there, yes, yeah. But there were not a whole lot of opportunities. It was pretty small in many ways compared to Toronto. But we were determined to show those people in Toronto that we were going to become as big and better than they are.
Did you come up with the idea of having to have a product to sell so that you could help your revenue line?
Not initially, no. But it became obvious once we got going that we needed tissue culture media, a lot of it, and it was quite expensive. And so we developed a way of making just the standard tissue culture media for growing all sorts of cells. And we sold that around the city and made a little money. And then later on, we had refined a lot of the reagents that you need to make really good media for growing blood-forming stem cells. And that was what we then focused on and started selling that. And we advertised it, and sales has shot up, and it became the world standard and remains the world standard.
When did you decide to set up STEMCELL Technologies as a separate company?
Well, in 1993, actually. So the board of the Cancer Foundation, I had about 10 people making media in the Terry Fox Lab, and they thought that it would be a good idea if I spun that out and made a company. And I that wasn't really my intent. I was happy just to sell the media, and the money was all going back to support the Terry Fox lab. But they thought that should happen, and there was a bit of a biotech bubble going on in Vancouver at the time, and I think they saw that as a possible opportunity. But I was very nervous of starting a company and getting investors, which was what a lot of people were doing, because I could see that they were pushing scientists to do more and more and more, and often it didn't work. And then the scientist was left, firing all those people that he'd hired, and it was not a nice thing. So the idea was to work very carefully and just grow the business slowly, and only based on our revenues, and that's what we did, and that's what we've continued to do for the last 30 years.
Where did you get the initial financing?
Well, I mortgaged our house in Vancouver, which it was $500,000 at the time. I bought it for $90,000. It's the same old house. We still live there. But the house prices have gone up. So I mortgaged my house, and I got a loan for $500,000 from Western Economic Diversification, which I've paid back, and that's what gave us the initial capital to get going.
Must have been some sleepless nights.
No.
No?
No, we knew exactly what we were doing. We knew our media was really good, people loved it, and it was flying off the shelf.
So the switch from scientist to entrepreneur was smooth?
Yes, definitely. In fact, I didn't pay too much attention to the business initially because I was still involved in cancer research, and I'd also become head of clinical hematology and was building our bone marrow transplant program in the basically 1980s and 1990s. I mean, it was there were a lot of things going on here, and we were starting graduate training programs that focused on cancer. Like there was no course, you couldn't get a course in cancer, and so I started the course in cancer and got all the pictures because the cancer agency documented people's cancers by taking photos of them. So these were of course anonymous, but I could show people this is what a cancer looks like. This is how it grows. This is what happens, and discuss the present treatments and the epidemiology of them and so on. So it was a great opportunity, and then there was then the medical departments wanted to have graduate students. So I helped to started not only the graduate students in pathology, their program, but the one in the Department of Medicine. And so that gave us more access to students. Maybe there was a little selfish impetus there, but no, there were all these people who don't want to do medicine, but are very interested in understanding the diseases and how to treat them.
It sounds like you really enjoyed teaching.
Oh yeah, because this was sort of new to people. I mean, cancer was sort of something you didn't talk about, and now explaining it and discussing it and having ideas about where to go with new therapies or new diagnostic approaches, that was very exciting. This is a wonderful period in our life on the planet. We can start to investigate all these things. I mean, it's just a huge opportunity. And of course, that's what happened with STEMCELL. We grew the company just on the basis of making media for growing blood-forming stem cells. But then all the other cell types that you would want, like breast, there's breast stem cells. And my wife pioneered the identification of breast stem cells. And getting the material for them is like we always wanted to work on humans. You can work in mice, but the idea is that humans are much more relevant. And of course, getting that material to do the research on it has always been a bit of a problem.
In the early days, people were a little worried about stem cells and where they came from. Were they embryos? Do you remember all that controversy?
Oh yeah. I'm a colleague of Jamie Thompson, who actually was got the first embryonic stem cells from, and he was all over he was cover of Time magazine, and got a lot of, but also took a lot of heat for that, right? And but it opened the way to understand early growth and differentiation of the ultimate stem cell, which is the fertilized egg. In 2006, Shinya Yamanaka developed a way of taking any cell and with several factors, getting it to become a stem cell. So now you could take any cell type, turn it into a stem cell, and then get it to differentiate into other cell types that you can study. So it made the embryonic stem cell thing really obsolete, but it did contribute to our knowledge. Yeah, and you know, people have different views on whether that's a good idea or not. I won't go there, but it did contribute, no question. But now it's a whole new world because you can take any cell in your body, turn it into a stem cell, and get it to differentiate into any cell you want. Now that's a dream still, but there's a lot of opportunity.
So really what you're doing at STEMCELL Technologies is having scientists help scientists. So it's part of the chain.
Yes.
You get the media set that they're going to need when they do their experiments in various places. That's right.
So I mean, a good example is in China when they were trying to they had the virus for COVID, but they weren't getting enough growth to get enough virus to get the RNA from it. So they switched to our media, our tissue culture media for growing pulmonary epithelial cells, and they got really good growth. And the virus, and then they inoculated those cells with virus, and they got enough virus to get the RNA, and then they distributed that to the rest of the world. And that's the basis of both the Moderna and the Pfizer vaccines that, you know, have changed the world.
Because of something that came out of your labs.
Yeah, we like to think of it that way, yeah.
Yes. Yeah. When you look at your company, one of the failings, I think, in the biotech field is that we've got brilliant minds and scientists and young people coming along, and they often have an idea and they get a startup going and they get it to a certain size, and then this offer comes along that they can't resist and they sell out. I'm sure you've had many offers along the way. Lots of offers.
Yeah, but I'm a Canadian nationalist, and we want to keep the science here, okay? And I'm, BC located as well, so I'm a bit, British Columbia has the potential to become a real biotech center, and it should. And I use the example of Ireland. Ireland has about the same population as British Columbia, 6 million, right? And they are the third largest exporter of pharmaceutical products in the world. And they have got this, now they've set the tax thing to attract these companies, right? But they've got a huge training program of all their young people, and they've populated, all these industries, these pharmaceutical industries with smart young Irish kids, and their business is booming there. But we're benefiting from this because they work in industry for a while, these young people, and then they want to see the world. And so we have over 120 Irish staff who are trained in, make pharmaceuticals, so understanding how to really work in clean rooms and do clinical grade product development. And they're a great help to us. And of course, the province has just licensed the training program that they have in Ireland to sort of finish training these people after they've been, say, with a BSc, to give them the skills they need in industry. So we're doing that here at BCIT now, so you put all that together, and the companies that are starting here in BC that I think are going to stay, and some bigger companies are coming in and buying those companies and keeping them here. So I would like to think that this is going to continue to grow and going to become a biotech center. And of course, we're the biggest biotech by far. And we've got all these training courses. We've got over 600 training courses. So we're training all these people. And yes, they come and poach them from us, but that's fine. They go and work in those other companies and they learn something else, and then some of them come back. So creating this ecosystem of really science-based companies is really what I think we should do. Get away from the resource-based economy and go for the knowledge-based economy.
And so what did Ireland do to create that ecosystem? And what should either BC or Canada be doing?
They have lower taxes than other countries in the EU, and they are in the EU as well, right, in the European Union. So they've benefited from that, but they have a good educational system, and they've just done it. But it's taken probably 30 or 40 years. I mean, I don't know where it really began, but we can do that here, and it's a good example. And also in Ireland, they have 6 medical schools. And in Dublin, half the students are Canadians. I mean, this is a travesty. I mean, we need more medical schools. We need more training for our people, and we need to become more prosperous to actually pay the medical profession, nurses and doctors and pharmacists, so they stay here in Canada. So that's the goal: is to have this, biological industrial complex linked with academia, with the support of government. The Irish sent somebody over here to try to get me to set up another facility in Ireland, and they had all sorts of inducements, like why they would find us a piece of land, they would find us architects, they would find us contractors to build whatever we wanted. If we had a service like that here, trying to attract biopharma into British Columbia, maybe this would be very helpful. So, we have to think big. We're not thinking big enough.
Why not?
I think that we just haven't been stimulated. Life has been too easy. It's been just getting all our natural resources and selling them off, and that's pretty easy, right? No, that isn't going to last forever. How do we now get a solid economy based on science, which I think is going to stand the test of time? And certainly the healthcare industry is the biggest industry in the world in all its complexity, and it's a growth industry. Everybody's getting older, and I would say probably wealthier, and they want to spend money on their health and live longer. And so there's a lot, but there's huge advantages to that. So the more money that goes into the research that supports all this industry is going to benefit everybody, right? But the biotech thing is the underpinnings of it. It's the underpinnings of the pharmaceutical industry, which then gives you drugs that go into you actually use into the actual healthcare delivery. So the idea is, we've got a socialized healthcare system here, which I'm a big supporter of, but it's it's just got this huge costs, right? And how do we think differently? How do we turn health care into a revenue generator? I've got 11 grandchildren, and they're definitely aware of the value of science. And 2 of them have just gone to university this year, one to take science and the other to take engineering. So
they did have a role model in the family.
Yeah. But we also have some role models here too. Like Tilna McCullough, with whom my wife and I trained in Toronto, are the fathers of stem cell biology, and I had a sculptor build a statue of Tilna McCullough, which is outside our science world, and everybody takes their kids to Science World on a rainy Saturday. So they have to walk by that statue, right? Hopefully that rubs off some interest in science and in stem cell biology and in biology in general.
So they were your mentors.
Yeah.
It's important to find mentors in whatever chosen career one has.
Yeah.
So you talk about your grandchildren and, of course, your children. How do you hope that they remember you?
Well, as someone who was passionate about making the world a better place, right? And as a passionate Canadian to be too, right? And how do we what is the legacy of Canada? You know, like so, and one way of looking at it is the boreal forest and the coastal forest. And we need to turn that into a national park, just like the Serengeti is. I mean, we need to foster, environmental sustainability.
So if you could look into the future, first of all, I don't assume you're going to retire. Any retirement plans?
No. No, I jokingly say I'm going to discover immortality through our understanding of stem cells, right? So I don't have to have any exit strategy. I'm going to live forever.
And what do you think will be the next big medical and health breakthrough? Not just from your position, but in healthcare?
Well, the treatment of cancer is, we're now understanding the role of immunology in regulating cancer. And that's a huge breakthrough. And those therapies are starting to become used, not nearly, they're not refined at all yet. They're just the beginning, but CAR T cells, taking T cells and genetically engineering them so they go after proteins on the surface of cancer cells and leave other cells alone is, this is mind-boggling. We're going to be able to have all these therapies that are based on being able to manipulate the genes in key cells to do things better than they are, and to keep them more focused on other things that are needed. So there's just all sorts of things that we can think of here. You see, the whole thing about what we do is understanding the growth of cells. It's a whole new way of medicine. Medicine typically has been taking chemical compounds and treating people with those. What we're talking about now is taking cells and treating people with new cells, either their own, which is an autologous way of getting the cells from the patient, doing things to them and giving them back, or having cells from other people that you can give them. I mean, like bone marrow transplant, of course, is taking now cells, bone marrow, from another person and giving them to the patient, right? Or from themselves, cleaning them, getting rid of the cancer cells, and then putting them back. So it's a whole new way of thinking about medicine.
I love your enthusiasm and how positive you feel about the future. Thank you, Allen, for everything you've done to move biotech forward in BC and Canada. Thank you. Dr. Allen Eaves, a BC legend.